Hi all, welcome to Cyber Warfare AWS Cloud Red Team course. In this module, we will discuss about one of the services provided by AWS, that is Virtual Private Cloud (VPC). So it's infrastructure as a services provided by Amazon. This service will help you to set up your own infrastructures on AWS, on cloud. Basically, it's similar like you have your infrastructure in on-prem. You have a router, you have a VLANs, you have a subnet, you have a internet gateway, you have a net gateway, you have access controls and all these things. Same thing you can replicate in the cloud. So VPC provide a way to set up your infrastructure in AWS cloud. So let's discuss about what are the services, what are the components there in VPC, and how we can misuse, how we can exploit those services. So first we'll discuss about introductions. You can see here we have divided into three sections. First we'll discuss about the introductions. Second, we are discussing about the components, just like VPC. We have a subnet, routing tables, internet gateway, net gateway, peering, endpoints, and network ACLs. And at the end, we will discuss about how we can perform a lateral movement or pivoting from one VPC to another VPC. So this is similar like when you're doing network pivoting or lateral movement within the on-prem infrastructures. Same thing we are going to simulate in a cloud environment. So let's discuss each and every one by one. Okay, so first thing is introductions. So Amazon Virtual Private Cloud, that's called VPC, let you provision a logical isolated section of the AWS cloud where you can launch AWS resources in virtual network that you define. So basically you can create your own logical isolations network within the cloud environment, so you can have your resources there, so nobody else can use this thing. Second thing, you have a complete control over the virtual network environment, including selection of your own IP range, creation of subnet, on configuration of route tables and network gateway. So basically it provides you the full functionality. You can set up your own infrastructure, whatever customizations you want to choose, your IP address, subnet, what access control you want to implement, and all these things in a isolated environment in the AWS cloud environment. So let's discuss about what other sections we have. So this is the overview of AWS VPC. So you can see here, this is the overview of AWS VPC. This is the VPC. We created a logical isolated environment within the AWS. This is the isolated environment in AWS. So whatever resources there in this VPC, nobody else can use. So this is the VPC. Within the VPC, you can see here we have CIDR. This is the IP range defined by this VPC. Maybe you have another VPC which is defined another IP range, but this is the VPC which have this IP range 10.0.0.0/16. So in this VPC, we have a two subnet. One is subnet which is defined this range, and another subnet which is defined this range. You should be noted that this range should be there within this CIDR of total VPCs. Why we call this is a public subnet and this is a private subnet? It's because of the routing table which is attached to this subnet. So suppose public subnet, we have this routing table. Why we call this a public subnet? Because you can see here in the routing table, the first route is defined to a local, because it's within the VPC. So every resources or EC2 instance within this VPC can communicate to each other. There is no restrictions. So this is why, because each and every subnet have a rule defined with this route. Now second thing, this is why this is called a public subnet. Why? Internet gateway is defined here inside the routing table. So routing table is really important, which will define you if this subnet is a private subnet or public subnet. So you can see here, other than this IP range, all IP range will be routed through this internet gateway. You can see here, this is the internet gateway. So all IP range dot means all IP range will be routed through this internet gateway other than the VPC CIDR itself. So this is why this is called a public subnet. When we're talking about private subnet, you can see here by default there is only one route is mentioned there, which is local, same like this one. There is no internet gateway attached to this one. So that means any EC2 instance or resources within this subnet cannot access internet. So there is no internet connectivity like that. It's blocked because we don't have any routing table here. But in this case, in public subnet, we have this routing table which will route all your traffic to this internet gateway, and you can access the internet from this public subnet. Second thing, you can see here each and every subnet have one network access control. So basically network access control attached on the VPC level but associated with subnet. So this subnet have one access control list, another subnet have another access control list. There may be a case that there is one case that there is one ACL which is attached to both the subnet, or there may be one routing table which is attached to both subnets. So it's up to you how you can define the how you can define your infrastructures in cloud. So basically NACL or routing table is associated with subnet level, not the VPC level, but is attached to VPC, but associated with subnet level. So let's discuss about what is routing table, what is ACL, what is internet gateway, and how we can do this. But this is the overview of VPC. Okay, let's move to another thing. Second thing, we are discussing about subnet. Sorry. So you can see here we have a two VPC. This is the VPC1 and this is the VPC2. Perfect. Now in VPC1 we have as many as subnet we want, but this should be comes under this IP range. So we have a three subnet, maybe one public subnet, two private subnet, one public subnet. It's up to you, but these IP range should be there in this. There is no conflict or there is no override. There is one more subnet, there is another subnet. So you can basically subnet is a range of IP address in your VPC. What does it mean? It's a logically divided large IP range into small subnet. So you have a VPC, this is the large IP range 26. You can divide it 26 into this 24, 24, 24. You can divide it up to more. So it's up to you how you can define your infrastructure. Same like in VPC2, this is the IP range 192.168.1.1/16. We divided into two subnet, 192.168.1.0/24, and another one is this one. Public and private subnet is defined by the routing table, what route you assign, what route you define there. So this is how you can divide it as many as subnet you want in your VPC. This is really important because I already discussed NACL or routing table is associated with subnet only. So maybe you in a single VPC you have a multiple subnet, and each and every subnet have a different NACL as well as their routing table. So during our enumeration phase or when we are performing red teaming, we have to understand about how many VPCs are there, and within the VPC how many subnets are there. Then also we have to check what subnet have what routing table, what NACL. So all these things we have to do in enumeration phase as well as our different red teaming phase. Okay, so this is clear, I think. So let's move to another point. Third one is a routing table. What is a routing table? So basically, as I already discussed, you can see here, this is the routing table I have, where we have to define the destination and the target. So basically routing table, what does contain? So it's contain the route informations, where the traffic should route. If it's a internet address, how does it route? If it's a local address, how does it route? So you can see here we have only local as well as internet gateway, but there is a lot more thing you can mention here. So here you have to define the destinations, the IP range, each and every IP range you can define here. But these are the things you should keep in mind. The first thing is local. This is a default and should be there by default. This is the VPC internal itself. So if you have a VPC, you have a multiple subnet. Each subnet have this route, because each subnet can communicate to each other. There's no barrier there. They can communicate to each other. Second one is internet gateway. So if any subnets or any resources within the this subnet want to access the internet, this subnet should have this routing table of internet gateway. If you define IGW, that means there is one internet gateway which is attached to this subnet or this VPC. Second one is NAT gateway. There may be a chance if this particular subnet doesn't have any public IP address but it still wants internet access, you can define by internet gateway. PCS, that's called VPC peering, that will allow to communicate to VPC. If you have two VPC, if they want to communicate those two VPC or resources within the two VPC, it can be done by VPC peering. VPC endpoint, this is a route which is defined by VPC endpoint. That means if you have any private subnet, but if you want to access any services, AWS services, which can only be accessible through internet, you can define this VPC endpoint. We will discuss about how we can do this thing. VPN gateway. So this is really important. If you want to expand your cloud to on-prem or your on-prem to cloud, you should have this VPN gateway connectivities. And last one is ENI, network interface. So maybe you have one EC2 instance have a multiple network interface. You can attach those interface and you can attach the routing for each and every interface. So suppose there is one EC2 instance which have a two interface, you can attach the route that another interface should have, the route should have follow this routing table. So basically it does contain the route. This is basically a set of rules called routes that are used to determine whether network traffic is directed. So it basically check the rules defined by a route, that how we can forward the traffic and where should the traffic should be forwarded. So this is how defined by the routing table, which is attached within the VPC but associated only with subnet. So if VPC have a one routing table, can be associated with a single subnet or maybe associated with a multiple subnets. So I think it's all perfect. Now let's move for another one that's called internet gateway. So a gateway that you attach to your VPC to enable communication between resources in your VPC and internet. So VPC is basically a virtual private cloud. That means there is no connectivity with internet. So you have to attach one gateway there to access the internet. So you can see here there is one VPC which have a public subnet, which have a private subnet. Why it's called public? Because there is internet gateway which is attached to this subnet, and whatever resources there, just like we have EC2 instance which have elastic IP which can access the internet here, but the gateway should be this one. So whatever thing is routed, it's routed through this gateway to internet. So this is how this thing works. You can see here in the subnet 2 there is no gateway attached to it. That means this subnet cannot access the internet. So basically it's provide a gateway to routed your traffic through your VPC to internet. It is really important to understand about, because when you're doing a red teaming, you will face that there is some EC2 which is hosting just like some application and it's allowed to access from the public. So definitely they should have one internet gateway as well as one public IP associated with it. Okay. Now E1 is the next one is NAT gateway. So basically there is a scenario. What is basically NAT does? So you can use a network address translations gateway to enable instance in a private subnet to connect to the internet or other AWS services, but prevent internet from initiating a connection with those instances. So it is really important for the security perspective. Let's discuss here. So you can see here we have a one VPC which have this CIDR, and within the VPC we have two subnet. One is public subnet, one is private subnet. In public subnet, we already attached the internet gateway as we discussed. So all your traffic routed through this one. But there may be a scenario in private subnet, few services want to access internet. Basically, to update something, to download something. How does it happen? So first scenario is you have to attach the internet gateway here. If you are attaching the internet gateway, this should have a one public IP address associated with this. If there is one public IP address which is associated with this one, that means anybody. So this subnet can access the internet as well as anybody from anywhere using the internet can access this subnet, and which is really dangerous because we need internet here, but we don't want expose the instance which is there in this subnet to the public audience. So this is how NAT gateway come into picture. So NAT gateway basically provide you one-way internet connections. That means it is routed through like that. If you want to access the internet, it's going through a NAT gateway which is there in your public subnet, and it's routed through the internet gateway to traffic. The best thing is, in just like public subnet, you can access this thing using this internet gateway, but for NAT gateway, nobody can access like that. So this is a cross. So nobody can access your instance from internet. So this is how it's really important. You can see here private subnet is a one-way internet connections via NAT gateway. When you're talking about routing table, so public subnet have this is the default route they have. And second thing, the public subnet attached with internet gateway. But when we're talking about private gateway, this is the default route they have, and second one is the route they have, just like all that address other than this address is going through this NAT, and NAT should be there in your public subnet. So NAT can access the internet gateway and can block the connection initiated from the internet to your private subnet. So this is how NAT will really important. Now we are talking about VPC peering. So basically VPC peering connection is a networking connection between two VPC that enable you to route traffic between them using IPv4 address or IPv6 address. Instance in either VPC can communicate with each other as if they within the same network. So basically it's just like you have a two VPC. This is the VPC1 and this is the VPC, another VPC-B. You can communicate within the VPC, but you can't communicate. So one VPC cannot communicate to another VPC because the name is itself saying it's a virtual private cloud. So it's basically private. You can't communicate to each other. But if you have instance here and you have instance here, and if you want to communicate to instance, you have to create the peering connections. So basically peering connection allows you to communicate from one VPC to another VPC. It's a bidirectional. You should keep in mind, if one VPC can access to another one, that means another VPC also can access the VPC1. So this is really important because in organizations, like something is exposed to a public which is not very critical, but something just like database which is really critical, which should be there in private VPC, and from VPC1 you can access to VPC-B. You can't access from the internet. So this is how when you're performing in red teaming activities, or we can say pivoting or network lateral movement type of activities, you should have two VPC, and you should check how the VPC peering is look like. So one VPC have how many peers there in another VPC and how the route is defined. So this is really important to check the peering connection or performing lateral movement or pivotings in our red teaming phase. The last one is VPC endpoint. So basically, what does mean the endpoint, VPC endpoint? So it enable you to privately connect your VPC to support AWS services. And VPC endpoint service provided by private link without requiring an internet gateway, net devices, VPN connection, or AWS direct connect connections. What does it mean? Like if you are in private VPC, and if you want to access just like bucket, S3 bucket, which can only be accessible through public. Just like we have a, the domains should look like s3 dot the whatever regions US East 1 dot Amazon aws.amazon.com. This is a domain for S3 bucket to access it. But think about a scenario. It can only be accessible through internet. But there is a scenario where if any of your services, just like your application, which is there in private VPC, which doesn't have any network connectivity, want to access S3 bucket, how can it be possible? Because there is no internet, no net gateway, nothing is there. So it can be accessible, or it will be accessible using VPC endpoint. So VPC endpoint basically provide you a way to access AWS's services without internet, net, or VPC connections. Sorry, VPN connections. For instance, your VPC does not require public IP address to communicate with the resource in services. Traffic between your VPC and other services does not leave your Amazon network. That should keep in mind that there is no internet connectivity here, so it's not leave your AWS network. So it will be there. It will be routed through VPC endpoint to access the AWS services. Let's discuss how it's possible. So you can see here there is one VPC, and this is the CIDR of VPC. If you are there in AWS, public subnet, and there is internet gateway is already attached to this public subnet. If any of the instance in this VPC, just like any of the EC2 instance want to access S3 bucket, it can only be accessible. So first it will send the request to internet gateway. It's going through the internet and this coming back, and then it will serve whatever thing you want to access it. Again, the same reason. So it will be redirect like that. So it comes here and the request will be, you will get the response in like that. So that in public subnet, it will leave the AWS environment. This is the AWS infrastructures I have, and it will leave like that. There may be a scenario if you have a VPC endpoint. This is the private subnet which doesn't have any internet gateway, VPN, or net gateway. Still you can access this S3 bucket, which initially can accessible through internet, but you can access it. So how you can access it? You have to create a endpoint. So that means you have to create a route. You can see here is a routing table. You have to create a route. You can see here this is the route, and which can only be routed through this. So it will not leaving the AWS infrastructure. It will be there within the AWS infrastructure, and you can access the AWS services. There is S3. There is a lot more services you can access it. So this is how, and this is why VPC endpoint is really important now these days, because you found in your red teaming that some subnet or some VPC doesn't have an internet connection but still can access the other services, RDS, S3, or there's a lot more services through this VPC endpoint. The main thing here is you should check the routing table first. If you check the routing table, you understand about how many routes, what are the services they are using, and how all the traffic is routed through one VPC to another VPC, or one subnet to another subnet. So this is how it's really important. Now at the last, we are discussing about network ACL. So basically, what does it mean, network ACL? So network access control list is an optional layer of security for your VPC. So it's similar like firewall, which is only allow or deny incoming or outgoing traffic. NACL is associated with subnet level. You can associate network ACL with multiple subnet. However, subnet can be associated with only one ACL at a time. So basically, what does it mean? ACL we can attach to a subnet VPC, but can associate it only the subnet level. So if you have a one VPC, you can see here in this case, we have a one VPC, we have a three subnet. This is the first, this is the second, this is the third. In first subnet, we have this ACL, which is, you can configure like who can, what are the port you exposed, how the ingress traffic works. So basically incoming bound means you can, from internet you are accessing this thing, Outgoing means from your within your VPC or cloud you can accessing internet. Second thing you can see here, we have another ACL, which is associated with two subnet. This is the subnet first and this is the subnet second. So this is how it will basically protect the port you want to expose, who can access and what they can access it. So it's basically protect your inbound and outbound connections. So it works as a firewall, which basically work on the protecting the unauthorized access. Or just like if you want to only expose a 22 port, but there is still few other ports in this instance level, just like 80 port is also exposed, but you don't want to expose this port, so you can set the rule or ACL on the VPC level at the as well as subnet level instead of instance level. Instance also have a firewall that's called security groups, which is protect on the instance level, but VPC is ACL, network ACL protect on the VPC level as well as subnet level. It's up to you how you can define the ACL. So this is about what are the services, what are the components is there. Let's check in a practical demonstration how it's really look like and how we can do all these things. Okay, so you can see here what I'm going to discuss here. Okay, so this is my AWS management console. I'm just going for a VPC, isolated cloud resource. And one really important thing in AWS, it's called a region. So it's basically, you can see here, currently I'm in Ohio region. This is called USA East 2. So there's everything is defined, everything is divided in AWS is basis of region, what region you are currently in. So if you haven't chosen another region, everything will be changed. Your resources, your VPC, everything will be changed. So this is really keep in mind that when you performing or when you are doing any red teaming activity, what region you choose, what are the resources based on this region, what are the resources based on other region. So you have to look on other region also, not only focus on the one region, but you have to check the other regions also. So let's see, currently I'm in Ohio region, US East 2, and this is my VPC dashboard look like. It will taking some time, let's wait for. Okay, so you can see here this is the dashboard of virtual private cloud. It's basically provide infrastructure as a services. You can see here all the services, what are the component, it will be mentioned here. So it's basically region based. So currently what region, what are the services there. So you can see here we have a VPC, we have a subnet. In this region we have these services. You can see here I already mentioned it's basically defined by the region basis. So if this region we have these services. You can see here this Ohio is mentioned there. So in Ohio region we have a 4 VPC, but by default each and every region have one default VPC. Let's see all regions, and you can see here we have multiple of regions, and each and every region by default there should be a one VPC that called a default VPC. So suppose if you're going to launch instance and you don't create any VPC, it will be there in default region. So each and every region have a one VPC. This is the region one VPC, and this is the Ohio region which I have a 4 VPC. Asia Pacific, it's taking time. You can see here US East, there is 2 region, but Ohio we have a 4 region. That means I created a 3 more VPC. One is a default VPC there. So that's why we should be keep in mind that while performing the red teaming activities, to understand about a region, how many regions are there and what services belongs to what region. So you can see here currently I'm in US East 2. We have a 4 VPC. We have a few subnet. We have a elastic IP, endpoints, net gateway. Let's discuss one by one. So first thing, let's click on the VPC. Okay, so you can see here we have 4 VPC within this region. One is default VPC, which is there by default, and these are the 3 VPC which we created. So you can see here what are the things there. We have a VPC1, VPC2, VPC. These are the 3 VPC. Let's click on the VPC1 to check what are the status of this VPC. So this is the details about VPC, VPC ID, DHCP options, routing table attached to this VPC. So the routing table is RT1 VPC1 attached to this VPC, network ACL which is attached to this VPC, and this is the CIDR of this VPC 10.1.0.0/16. This is the CIDR I already mentioned there. Flaw logs, how we can access it, that's a different thing. So this is how you understand about a VPC. In VPC1, what are the things there? What root, routing table, what network access control. The similar thing you can check about VPC3. Just like VPC3 have this 10.3.0.0.0/16. VPC2 have similar like this is the CIDR block 10.2.0.0/16. So this is how VPC divided. VPC have a VPC ID, routing table, X, ACL. So this is important. VPC have a VPC, routing table, and ACL. Now let's click on the first VPC, or you can go here in subnet. We understand that there is a 4 VPC. One is default VPC, and other one is we created the VPC for our infrastructure. So you can see here we have a VPC, we have a subnet. Subnet basically it's a logical part of a VPC. So you can see here in VPC first, you can see here in the VPC this is the VPC1, this is the subnet. So subnet 2 in VPC1, and this is the subnet 1. So let's this. Okay, you can see here we have a 2 VPC. In VPC1 we have a 2 subnet 1 and subnet 2. So this is the subnet ID, but VPC ID is the same. So VPC1 have a 2 subnet 1 and subnet 2. VPC2 also have a 2 subnet. This is the subnet. VPC3 have also subnet. This is the subnet, and this is the default VPC which have a 3 subnets. These are the subnets. So default VPC. So this is how we divided the subnets. And what is subnet? Let's discuss about VPC1. We have 2 subnets, subnet 1 and subnet 2. What are the information there? VPC ID, routing table, network ACL, and this is the subnet information. This is really important. So there is 2 root. This is the routing table which is attached to subnet 1. When we're talking about subnet 1, this is the routing table attached to it. Network access control which is attached to this subnet. So this is how we can check the subnet, what is there in this subnet. In details you can check what are the IP address which belongs to this subnet. So this is the IP address. In VPC we have IP address like 10.1.0.0/16, but in this subnet we have a 10.1.1.0/24, and this is the subnet which we have IP address. This is the subnet we have IP address like 10.1.2.16. So this is how we divided a large VPC into a small logical network, where we have a 2 subnets. Okay, so VPC completed. We discuss about VPC, we discuss about subnet. Now the important thing what we are going to discuss is in network, or we can say routing table. So you can see here in this VPC, let's go for a routing table. Okay, you can see here this is the routing table we have. Let's check this one. VPC, this is the VPC1, routing table of VPC1. We have a 2 routing table for VPC1, but VPC2 and VPC3 have a same routing table. So this is really important, that routing table is attached to VPC but associated with subnet. So you can see here 2 routing table. This is association with this subnet, and the another routing table which is association with this subnet. All these two subnets belongs to VPC1. So this is how you can divide it there. You have a different routing table for different subnet, and you have a same routing table for different subnet. So two routing table, one is within two routing table which is there in VPC1. One is associated with only one subnet. This is the association. So this is really important. Let's discuss about first routing table. Route first. In our VPC, we have a two subnet and we have a two routing table. The first one is associated with this subnet. So this is the subnet, this CIDR block, and this is the routing table. This is really important about what route they have. So you can see here this is the route IP address range, and this is the route. IGW means internet gateway. That means this is the public subnet. Why? Because routing table is saying that this is the public subnet. Why? Because internet gateway is attached to this subnet. Let's discuss about same VPC with another routing table. You can see here this is the routing table. This is the subnet which is associated with here. And what about route? This is the default local route within the VPC. This is the 0.0.0. It's attached to net. There is no routing table. There is no internet gateway attached to it, but there is one net gateway which is attached to this VPC. And at the end you can see there is PCX, means peering. So there is maybe some another VPC. This VPC have peering with those VPC. So this is how it's important to check about routing tables and understand about how the peering is happening on all these things. Let's discuss about VPC2. Sorry, routing table within the VPC2. So you can see here in VPC2 there is one routing table and both the subnet attach the same routing table. What about the route? This is the route you can define. The first is default local. Second one is this is called VPC endpoint. So suppose if you want to access s3.ec2. East US Amazon.aws.com. Suppose if you want to access the S3 bucket within this region, you can access it. There is no net gateway, VPN attached to here, internet gateway, net gateway, VPN attached to here, but still you can access these IPs. Still you can access the S3 services using this VPC endpoint. There is two more things here. VPCX, PCX. That means VPC peering. That means any instance within these two subnet can access the VPC1 as well as VPC3. So that means VPC2 have a peering with VPC1 as well as VPC3. Same like if you go for a VPC3, this is the local. You can see here still you can access the S3 services because endpoint is active here, and at the end you can see here peering is also mentioned here. So using a routing table you can check how two VPC can communicate. Is there any internet gateway or net gateway attached to this one? So this is how you can define all these things. So this is all about we have about routing table, how it's look like. We are talking about NACL, network access control list. So you can see here we have a 3 VPC, and 3 of the VPC have only single NACL. You can have a multiple NACL which is attached to subnet level, but we have a 3 VPC and each VPC have a single NACL. You can see here the association here is really important. Maybe in given VPC you have one VPC attached to routing table but associated with different subnets. So try to understand about difference between attachment as well as association. So this is really important. Routing table or NACL attached to VPC but associated with subnet level. So when we're talking about VPC1, this is the VPC1. Routing table does what is contained is basically inbound or outbound rule. How they can block the rules for connection. You can see here. So by default, you can see at the bottom, by default it will block all the connections. That means nobody can access this instance within this subnet from internet. So it's basically, you know, by default it's have inbound block all these things, but as soon as you created the rule, whatever rule comes top, it will be first check. So you can see here the first rule we created is all traffic is allowed. This is the first executed, and then this will be executed. So this is a no matter because already we have allowed this one, but by default you can't change this one. If you change the route, you can't change the last one, but you can change the upper one. You cannot change this one. By default all the traffic is blocked, but you can change this one. So this is the incoming rule and same like outgoing rule. So that means in VPC1 there is no restrictions on the, you know, network level on the VPC. Similar like when you talk about second, you can see here in VPC2 only person can access SSH. That means only SSH is allowed from incoming connections. That means from the internet or from another VPC, anybody can access only SSH, whatever, you know, instances you have in this subnet or this VPC, because it's attached to both the subnets. So that means we are saying it's a VPC level. And outgoing rule, it's allow. That means whatever instance in this VPC can access anything, but nobody can access other than 22 port. So this is how you can define it. And you can see here only source, only VPC1, the instance within the VPC1 which have this IP range, which is VPC1 IP, can access the, you know, resources in VPC2 on this port, not the other port, not the other sources. So this is how you can define, you can control the traffic or firewall at the, you know, network level itself, network layer itself. Similar like we have a, you know, VPC3, NACL on VPC3. This is associated with both the subnet, and this will allow all the incoming and outgoing traffic. So this is how you can, you know, set all these things. So suppose there is one instance which have 82 port and 22 port, but you can only expose the 80 port to the public, and you can block all these things, all the instances with 22 port by this NACL. So basically it work on the network, you know, level, not the you know, instance level. So we have a subnet group, or we can say security group, which is work as a, you know, instance level. So this is the difference between these things. You can see here we have an endpoint, just like I discussed. We saw the routing table, we have an endpoint. So this is endpoint for VPC2, this is endpoint for VPC3. You can see the information. That means in VPC2 there is no internet connectivity. You can still access the S3 bucket, and this is the subnet, this is the routing table which is attached to this one. So that means for two of the subnet in this VPC, if any of the resources, for instance within this VPC or any of the subnet can access S3 these services, because this is routed through not the internet. It should be accessible through internet, but if you have this endpoint, you can access this thing using this VPC endpoint services. This is really important about peering connections. So peering connections means why it's important, because if you're performing a red teaming, you should understand about what is peering connections. You can see here we have a 4 VPC. Let's discuss about, we have a 4 VPC. VPC1, VPC2, VPC3, VPC4. Now one is default VPC and other one is 3 VPC. That means whatever services or resources we have within the same VPC can access each other. But resources from VPC1 cannot access anything on the VPC2 or VPC3. Why? Because we called it a private cloud, and we created as a private, so that means there is no communication. To make it say communicating, so that one you know, any resources within the one VPC can access the resources to another VPC, we have to create this peering connections. You can see here, that means there is one peering VPC1 to VPC2, and there is another peering from VPC2 to VPC3. Okay, so you can see here there's a two peering. Now when we're talking about VPC1 have a peering with VPC2, what does it means? Requester VPC, this is a VPC1 ID and this is the VPC2 ID, and this is the CIDR. So that means if you are in this VPC, can access anything within this VPC or this IP range, or vice versa also. If you are in this VPC, you can access anything within this VPC or this IP range. This can be happen through VPC peering. When you see the routing table, you understand about all these things. There is two routing table which is attached to this one. Same like when you have a VPC2 to VPC3. Let's discuss. So that means anybody within this VPC2 can access the VPC3, and anybody within VPC3 can access to VPC2. But there is one thing, keep in mind that you can see is VPC1 can communicate to VPC2 and VPC2 can communicate to VPC3, but there is no peering between VPC1 and VPC3. That means VPC1 cannot communicate to VPC3, or anything resources easy to instance within the VPC3 cannot communicate to VPC1. This should keep in mind that, because there is no route defined. If you are accessing anything within the VPC1 to VPC3, there is no route defined. So no route is not there. No routing table is have this route, so you can't access this thing. But when you perform the red teaming exercise, you have to understand about how we can perform the pivoting, how we can use the VPC2 to make a pivot point to access the VPC3. We will discuss in our coming exploitation session how we can use this thing to access another VPC or VPC which is the route is not there. So when I'm discussing the last part is routing table. So let's go for this routing table. Okay, let's close this one. So this is the routing table I have. Simply when we're talking about VPC1 routing table, this is a routing table of 2 of VPC1. You can see here when we have a route, we have this PCX, means peering connection. That means if you are in this subnet, not in other subnet within the, but this is also there part of VPC1. You can see here this subnet doesn't have a route to VPC2, but this subnet does have. You can see here. So that means if any instance within this subnet can access the resources of another VPC2, because this is the IP range of defined by VPC2. So this is the peering connection which make this route, and this is the route which is defined here. When we're talking about VPC2, there should be a two route, because VPC1 and VPC3. So if you are in VPC2, we can communicate to VPC1 as well as VPC3, and this has happened. And so it will associated with both the subnets. So that means any of the instance within any of the subnet can access VPC1 as well as VPC3. Same like VPC3, it's have only one route which is defined that if you are in VPC3, you can access the VPC2, but you can't access VPC1. So this is how we, by looking the routing table, we understand about how the route is defined, how we can check it. So this is all about VPC, how we can create the VPC, what is look like, what is subnet, what is net gateway, what is endpoint, and how we can access all these things. So let's discuss how we can exploit each and every services, how we can enumerate the VPC, enumerate the services by commands. Everything I show you is here is a UI methods, so graphics interface. But what about if you have a key? We don't have a console access. If you have only key, you compromise a key. How you can do all this thing by using only the we can say AWS CLI or API, only the command line utilities basically. So we'll discuss enumerations and exploitation part in our coming sessions. So this is all about the VPC, the services, and everything. Now in our coming section we will discuss about the exploitation part. This is called lateral movement and pivoting, as well as enumeration, how you enumerate it and how you can do all these exploitations using the command line methods. So this is all about this video. Thank you so much for watching this video.